In this lesson, we'll show how to express a force as a Cartesian vector using a position vector to define its direction. Let's review the basic idea. Say, for example, we have this force which acts along this cable, where we know the location of the endpoints of the cable. We can formulate a position vector from one end of the cable to the next. We find the magnitude of this position vector and divide it into the vector will form a unit vector, which defines the direction of the cable. As a result, if we know it, we can multiply it by the magnitude of the force, and we can thereby create the force F as a vector. Here's the formulation that's used to do this. Again, the magnitude of the force times the unit vector in the direction of r, and of course, in the same direction as F. So let's use this idea now to solve a few problems. We'll consider this one first. We want to express this force as a Cartesian vector. What would you do first if you want to solve the problem? Well, I form a position vector going from A to B. Notice that it has three components, one along the x-axis, the y-axis, and then, of course, along the z-axis. R is equal to what? Minus 2i. You'd have plus 2j. And finally, you would have minus 1k. Now we need to form a unit vector in the direction of r, and also in the direction of F. So we need to find the magnitude of r. What would that be? Well, it's the square root of some of the squares of these numbers, isn't it? It essentially becomes the square root of 9, or 3. And of course, it's in meters. It refers to the distance from A to B. So now we can form a vector, can't we? And what we do is we simply take its magnitude, which we know to be 600, and we multiply it by the unit vector, found by taking the vector r and dividing by its magnitude. So the first term would be minus 2 divided by 3, I, followed by plus 2 divided by 3, j, and finally you would have minus 1 over 3, k. And when you multiply this out term by term, you get our result right down here. Notice that the magnitude of this would have to equal 600. You can check that if you care to. And one last thought. I can define alpha, beta, and gamma for the force F by simply finding the arc cosine of each of the components of the unit vector that define the direction of r and F. For example, the arc cosine of minus 2/3 is equal to alpha, isn't it? The angle made between the positive x-axis and the tail of the force, and so on. All right, now let's repeat the process for this one. If you care to, you can stop the video and see if you can get the result. But anyway, I'll work it out for you. So first we have to form a position vector going from A to B if we're going to write this force as a Cartesian vector. Here's our r vector, and it has three components. One in the minus k direction, another in the positive j direction, and finally one in the positive I direction. That vector r is equal to what? Well, it'd be 4i. You'd have plus 2j. And finally, you'd have minus 4k. Next, we have to find the magnitude of this vector. You have any idea what that would be? Square root some of the squares of these numbers. In other words, the square root of 36. Comes out to be 6 meters, of course, the distance from A to B. And now we can create our force as a Cartesian vector. All we do is we simply take its magnitude, 600. We multiply by the unit vector u. That's this one, that acts in the direction of r and F. If you want to write that out, what would be the first term? Well, it's 4 divided by 6, I. And next we have plus 2 divided by 6j. And of course, our final term is minus 4 divided by 6, k. There we go. Multiplying out the terms, you get the result right here. Finally, we'll do this one. Here we want to express this force as a Cartesian vector. And so to do it, of course, the first step would be to produce a position vector going from A to B. How many components will it have? Well, it only has two, doesn't it? One along the x-axis and one along the y-axis. If I write it out, it becomes r equaling minus 2i, and of course, plus 2j. There we go. Now we need its magnitude, don't we? You know what that would be? It's the square root of 8, isn't it? I'll write it as 2 times the square root of 2, which is really the same thing. Now I'm ready to produce the force. F has a magnitude which is equal to 100 newtons. And it has a direction defined by the unit vector, shown here, to be equal to what? Minus 2 divided by 2 square roots of 2. And this is I, of course. Then we have plus 2 divided by 2 square roots of 2. And this is our j component. There we go. Multiplying everything through, you get our result, which is shown here. And so having completed the problem, we'll end our lesson.